Welcome back to Low Stress Math with Mrs. Bono. We are in Chapter 6, Systems of Equations. Don't forget to write your name, period number, and you can write your group number, but we're not going to have groups in a little while. We're going to be everybody in school together every day soon. It's getting exciting. Okay, so lesson 1, yeah, it always starts with a little vocabulary. Let me make this big enough for you to see, and we'll write some stuff down. A system of equation is two equations graphed on the same coordinate plane. A solution to a system of equations is the point where the two equations cross. It's not so bad. Well, it's actually the coordinates of the point where the two equations cross. Coordinate. Yeah, I'm having a good day. I can't spell coordinate. All right. So the coordinates of the point where the lines cross. I just want to point out that this is for linear equations. Sometimes you have nonlinear equations that are a system, and they can cross at more than one point. And we'll talk about that later, but right now we're just talking about lines. So we're talking about the coordinates of the point where the lines cross. That could also be called the point of intersection. Yeah, we should definitely highlight that. So I'm going to use those two terms, solution of a system and point of intersection, interchangeably. Most of the time, I'll say the system of equations. Every once in a while, I will mess that up, though. All right, so no solution means the lines never cross. What is that? The lines never cross. I want you to think about that. What kind of lines never, ever cross? Yeah, parallel lines. That's right. Parallel lines never intersect, so there's no solution to parallel lines. Back when we were doing equations and there were equations with no solutions, it's very much like that. So, the lines never cross, the lines are parallel. A system of equations that has infinitely many solutions. Remember there was one solution, no solutions, and infinitely many solutions? And when you have lines that have infinitely many solutions, they graph to the same line. The equations graph to make the same line. Both equations graph to the same line. All right, so let's take a look at my examples down here. Right here, you can see the lines cross, so there is one solution. Right here, where these lines cross, the coordinate for that, which is 1, 2, that's the solution to the system. The lines cross. So there is one solution. Now these lines, the lines are parallel. So there are no solutions to that one. Now this one, they have the same slope and the same y-intercept. The lines are the same. So there are infinite solutions. spell infinitely wrong too now. Infinitely many solutions. All right, now I want to go back up to the top. You can usually tell before you graph the equations whether you're going to have one solution, no solutions, or infinitely many solutions. Remember, if they have different slopes, so what does that mean? Think back all the way back. That means different m's. So if they have different m's, like, y equals 2m and y equals a half m, those are different m's, so those lines will cross, and they'll have one solution. But if you have the same slope, same m, and the different y-intercepts, so different b's, excuse me, then they're going to be parallel. So these two lines, they have the same slope, and the slope is 1, positive 1, 1 up, 1 over, 1 up, 1 over. But their y-intercepts, this one has positive 1, this one has negative 1. So they have different y-intercepts, but the same slope. This one has the same slope and the same y-intercept. They both intercept at 1. So if the same slope, same y-intercept, so same m and same b, then guess what? You have yourself the same line. That means that there's infinitely many solutions. So I just am going to go back and highlight those things because it's kind of important to know before you graph what you're graphing. So let's take a look at the next page and try a couple of these problems. So before I do anything, I'm going to look at the equations. Now look, I have the same slope. So the same slope. What does that mean, Bono? It means it's either going to have infinitely many solutions or it's going to have no solutions. So let's start with same slope. M equals 3 for both of them. But they have different y-intercepts. They have b equals 2 and b equals negative 2. So that means that these lines are going to have what? No solutions. These are parallel lines. So I'm just going to write that over here. Parallel lines. So this is going to have no solutions. No solutions. So let's graph them. I'm going to graph this first one in black. So I'm going to start at positive 2, and I'm going to rise 3, run 1. And I'm going to drop 3, go left 1. Yep. Now I have lots of little points going across. And if I didn't lose my ruler again, Bono, you are like the worst with your ruler lately. I don't know about you. You're just a big giant ruler loser. Here we go. As I throw everything all around my desk. Here we go. I'm going to connect those dots. There they go. And now I'm going to write the equation of this line, y equals 3x plus 2 on the line. Now to graph this line, I'm going to change to red, and I'm going to start at negative 2. But remember, I have the same slope, so I'm going to rise 3, run 1. Rise 3, run 1. Rise 3, run 1. Or I could drop 3, go left 1. That's another way to do it. And look at that. Just like I said before I even started to graph them, I knew these lines were going to be parallel. Same slope, different y-intercepts. And this is y equals 3x minus 2. Definitely no solutions. Now this one, Look at that. Same slope, same y-intercept. So let's write that down. All right. Same slope. M equals -3/4. Remember, that's rise 3, go left 4. But they also have the same y-intercept. B equals 3. So I'm going to start at B equals 3, and then I'm going to rise 3 and go left 4 to get my next point. Or I could drop 3 and go right 4. And look, there's my line. And it has same slope, same y-intercept. That means that I can actually just kind of go slightly down, and I'm going to put this other line so that it's just exactly the same. So now I'm going to write both of these equations, because y equals -3/4 x plus 3, and y equals -3/4 x plus 3. And don't forget to put your arrows on there, Bono. You're going to lose credit on silly things. So there it is. They're the same. They have infinitely many solutions. I should be highlighting that. Come on, Bono. Infinitely many solutions. And up here, we had no solutions. Now, these examples, I'm looking at different, because this one has 1, this has 2, this has a half, this has 1. They have different slopes and different y-intercepts. Haha. That means there's going to be one point of intersection. So let me just grab some other colors here. I like colors. So this one, M equals 1. So 1/1, rise 1, run 1. And B equals 2. So I start at 2. B equals 2. And from there, rise 1, run 1, until I have lots of points. And you know me, I like to follow the pattern and go in the opposite direction. So I have points all the way across my grid, my coordinate plane. Many, many points on my coordinate planes. Here we go. And arrows on each side. And I'm going to write the equation down over here. Y equals x plus 2. Always write the equations when you have more than one on the same line. That can cause problems. All right, so for this one, M equals 2/1. I'm going to rise 2, run 1. And I'm going to start at B equals 1. So here I am at B equals 1. Rise 2, run 1. Ah, look, I already have the solution. It's going to be right there. So then I'm going to drop 2 and go left 1 to get some more points. And here we go. La, 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 la. Lots of points. Arrows on both sides. And I'm going to write the equation on the line. Y equals 2x plus 1. And now, where they cross, this point here, I'm going to circle it. And I'm going to write the solution right here. I don't want to lose my solution. It's 1, 3. There's another way you could write that, though. You could write it as x equals 1, y equals 3. Sometimes that's how they write the solution. But that's my solution right there. Loving it. I'm loving it. Don't do that, Bono. Nobody wants to listen to you say. Okay. Next one. Ooh, look, that's got a negative slope. M equals -1/2. So I am going to rise 1, but I'm going to go left 2. And where do I begin? B equals -1. So I begin at -1 all the way down here, and I'm going to rise 1, but I'm going to run left 2. Rise 1, left 2. Whenever it's negative, you go to the left. Or if you want to put more points, you could drop 1 and go right 2 and get some more points going in the opposite direction. And connect the dots. Make sure you kind of straight. It's important to connect the dots, or at least have the dots on the points, because when you're looking for a solution, it could be any of these points. So you want to make sure that all the points are easy to see. And let's do the other one. So here, m equals rise 1, run 1, and I'm going to begin at -4. So I come all the way down here to -4, rise 1, run 1, rise 1, run 1. Oh, there's my point of intersection. And there I'm going to go all the way across and the other way, because I like to have lots of points. Here we go. Arrows on both sides. And I'm going to write the equation right here. Y equals x minus 4. And, oh, I did not write this equation. Silly Bono. Y equals -1/2 x minus 1. And where they cross, right here in the middle, is at +2, -2. +2, -2. And remember, that could be written as x equals 2, y equals -2. Those are both the solution to this system. The coordinate pair is a solution, but also x is 2, y is -2 is a solution. So let's take a look at the next one. So many problems on this page, Bono. You're just full of problems. Oh, look at that. X equals 2, y equals -6. Now I have to start thinking, right? X equals 2, y equals -6. Oh my goodness gracious. There's no slope. There's no y-intercept. What do I do? Ah, I remember. X equals 2. That means no matter what y is, x is going to be 2. So, x is 2, y is 0. X is 2, y is 1. X is 2, y is 3. It could be all of these points. This is going to be a vertical line. A vertical line is just straight up and down, and it doesn't have a slope or a y-intercept. It has no y, because I never crossed the y-intercept. I don't intercept that. So I'm just going to have this vertical line here. Now this one, y is -6. So let's say x is 1, y is -6. X is 2, y is -6. X is 3, y is -6. So I know now that this is the horizontal line. It never intersects, well, it intersects the y at -6. There we go. So this one down here is y equals -6. And this one here, which I did not put arrows on because I am a fool, is x equals 2. And where they cross, right here, is at +2, -6. Oh, wait a second. +2, -6. Right there. I already had the solution. Silly Bono. But that's the coordinate, or you could write it like this. Wait, x equals 2, y equals -6. Make that better negative. There we go. Not so bad. All right, now here, the y is on top. Why would they do that? I don't know. But that's going to be the horizontal line. And I'm going to go to y is 3. And then it's going to be a horizontal line right through 3. So there's my horizontal line at y is 3. What does that mean? No matter what x is, y is 3. So x is 0, y is 3. X is 1, y is 3. X is 2, y is 3. All of that. So I'm going to just write that right on here before I forget. Y equals 3. And now x equals 4, that's the vertical line. When there's no y, what did I do? Vertical, C-A-L. Come on, forgetting letters here. negative 4. No matter what y is, x is negative 4. So I put a negative 4 on the x line, and it's going to be vertical right through there. Oh, that didn't come out very good, did it? Here we go. Arrows and labels. Don't forget your labels. X equals negative 4. And where they cross, right here at negative 4, positive 3, or you could write it, oh, where am I? I'm over here. I could write it like this. X equals negative 4, y equals negative 3. That's the other way to write the solution. Or I could just write it like a coordinate. Okay, I got 2 more, and these are the hard ones, and I was saving them for the end. Why, Bono? Why would you do that? Because look, they're not written in the right order, but these are easy enough. I just have to put the y on the opposite side. So I'm going to rewrite this one as y equals 2x minus 6. Ah, now I got it. So now I have m equals 2 over 1 and b equals negative 6. So I can graph that one. Here we go, negative 6, and then rise 2, run 1, and I'm going to have a nice line go straight across up like that. La, 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 la. There's my first one. The second one, of course, is going to be more difficult because isn't it always, right? So first, I'm going to flip and put the y in the front, right? But I also want to reverse these two. So I want it to be negative 1x plus 3. Because see, 3 is positive and x is negative. And you want the 1 because you want to see the slope. So let's do that one in pink because pink is pretty. So my m equals negative 1 over 1, which means I'm going to rise 1. But remember, when it's negative, you go left. So it's the negative is in front of the x. So it's rise and left. But the 3 is positive. So b equals 3. That's positive 3. And a rise and go left, rise and go left, rise and go. Oh, but I didn't hit the line. So I can drop and go right, following that same pattern. And there I found my spot. And there we go. Straight across. Now, I didn't label these yet because I got to talk about that. Get back to that in a second. Well, first put the arrows, and also you always circle the point of intersection, and this is 3, 0, 3 to the right, up 0. Now, how to label these two lines. You always label them with the original line. So the original line here, the original equation, 2x minus 6 equals y. 2x minus 6 equals y. And then this, the pink one, I had to write it sideways, here we go. 3 minus x equals y. You always have to go back to whatever the original equation was. And the last one, this one. Now this is the same, I just have to flip-flop and put the y on the other side. So I get y equals negative 3 over 2x plus 2. So that means my slope m is 3 over 2, negative 3 over 2. So I'm going to rise 3, but I'm going to go left 2. Rise 3, left 2. Be careful. But I'm still going to begin at 2. So I'm going to begin at 2, and I'm going to rise 3 and go left 2. But I can only do that once. Now I can do the opposite, which is drop 3, go right 2, drop 3, go right 2. As long as I'm following the pattern and my points are in a straight line. I want my points in a straight line. And connect those dots. There we go. And now I have to do the same thing here that I did here. The x is going to come first and the negative 2 is going to come second. So this is going to become y equals 1/2 x minus 2. That means that the b is what did I just write? I wrote b instead of m, and I don't even know where I put my whiteout, blah, 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 blah. Oh, we can't be listening to that. That's horrible, that's awful. No. Goodbye, unknown caller. Right in the middle of the highlighting and everything. All right, so this is m equals 1/2. So I'm gonna rise 1, and I'm gonna run 2. And my b equals -2. So I'm gonna begin at the b at the back in the -2. Right down here at -2. And I'm gonna rise 1, run 2. Oh, look, I already got my answer. I love it when I get the answer right away. Makes me happy. Now, connect the dots. Arrows. And this is my solution right here where they cross at 2, -1. Now, oh, I almost forgot to put the equations on the lines. Look at me. Remember, you have to go back to the original equations. So this is -3 over 2x plus 2 equals y. And then this one is -2 plus 1/2 x equals y. Okay, everything's labeled, clearly have an answer. Oh, you could also write the answer as x equals 2, y equals -1. That's the other way to do it. All right, I will talk to you soon. Good luck, and have a great day. Bye.